should have listened.
That's okay. You can still be there. It'd be nice if you do the discussions and the quizzes and things. I'd have to put zeros. Anyway, now we have an alternating series. So in 38.3, we've got some series, and I got a minus 1 to the n plus 1. N goes from 1 to infinity. And now I'm gonna have a an. So I'm gonna have something that's when n is 1. So it'd be a1 minus a2 plus a3 minus a4. So now I've got something that's alternating plus and minus. And the sines and cosines, for example, alternate plus or minus. So that seems like a reasonable thing to do. And now we want to know whether or not the alternating series is going to diverge or converge. So the first case we need to have is we need to have a 0 less than an plus 1 less than an, or all n greater than or equal to 1. So if the newer guy isn't smaller or the same as the guy, it could be the same as, right? Because if it was the same, then we could do it plus and minus, and then it's going to add up to 0, and I'm going to converge. But if it's not smaller, if it's getting bigger, then this is going to diverge. We also need another condition, and that's the limit of an as n goes to infinity has to be 0. So as long as this guy's getting smaller than the guy before, or the same as the guy before, and as I go to infinity goes to 0, then this guy is in fact going to converge. So converge. But I could if he because let's say I had something that was minus 1 plus 1 minus 1 plus 1 minus 1 plus. Is that going to converge or diverge?
It's going to be 0.
It's going to diverge. Now, why is it diverging? Well, it misses the b part, the limit as n goes to infinity of an has to be 0, and it's not. But this guy here, well, what's happening is I have a point there, I got a point here, I got a point there. Well, I got a point there, and then I'm at 0. I got a point there, I'm at 0. I got a point there, I'm at 0. So to converge, it has to converge to a point, but every time I add something to it, I go to the same place I was the time before, and so I'm not converging on anything. So that's the issue there. Okay, the other thing is we could have absolute, or conditional convergence. So if in fact I have some summation n equal 1 to infinity an, if this guy converges, then we say that the summation n goes to 1 to infinity of an converges absolutely. And if we have the summation n goes to 1 to infinity and an, if it diverges, but the original guy does in fact converge, if this guy converges, then he converges conditionally. Almost got enough room. So the plus and minus is required for this guy to converge. It's not required for the other guy to converge. So absolutely, converges absolutely. I don't have to be plus or minus. Converges conditionally. the plus or minus has to be there in order for it to be true. Okay, time to work exercises. Number 1. So imaginative, I picked one. So determine whether each series converges, diverges. If it converges, whether it converges absolutely or conditionally. Okay, so that's the story. So I got summation n1 to infinity minus 1 n plus 1 1 over 2 n plus 1. All right, so the first thing I look at is 0 less than 1 over 2 n plus 1 plus 1? Is that less than or equal to 1 over 2n plus 1? So that's the question. Is this guy 2n plus 3? Is he less than or equal to 1 over 2n plus 1? And the answer is yes, that is true. Does the limit of 1 over 2n plus 3 as n goes to infinity, is that 0? Is that equal to 0? That's the question. And that's the second part. Okay, so I'd take the limit, n goes to infinity, 1 over n plus 2n plus 3. I'd multiply top and bottom by 1 over n. Limit, n goes to infinity, 1 over n, 2 plus 3 over n. And we notice that this guy goes to 0, that guy goes to 0, the whole thing goes to 0. So that is also true. So that being the case, this guy converges. So let's say, so we know it converges. Now the issue is, does he converge absolutely or does he converge conditionally? So I'm going to look at summation n equal 1 to infinity of 1 over 2n plus 1. And I'm going to go back and use my ratio rule and look at the ratio. R is equal to the limit, n goes to infinity, 1 over 2 n plus 1 divided by 1 over 2n plus 1. I have 1 over 2n plus 3 divided by 1 over 2n plus 1. I'm looking at limit, n goes to infinity, and so I got R is 2n plus 1 over 2n plus 3, limit, n goes to infinity, and I find that that's 1. The test fails, right? So if I'm equal to 1, the test fails. So now I have to use the integral test. I have to look integral 0 to infinity of 1 over 2n plus 1 dn, limit b is going to go to infinity, and I'm going to make this be a b up here. Okay, so this looks like limit b goes to infinity, natural log 2n plus 1 divided by 2, evaluated at 0 and b. Okay, so when I put in 0, I get natural log of 1, which is 0, over 2. That'd be a minus sign because it's the other guy, plus. I put the b in, the limit, b goes to infinity, natural log 2b plus 1 over 2. This is undefined because of our work last week. We know it's undefined. Therefore, it diverges, which implies this series converges conditionally. Well, that was too much work. Number 10. It's better if they just did, and then we wouldn't have to worry about it. 10. So I've got the limit, I got summation, n equal 1 to infinity, minus 1 to the n, 1 over n factorial. Well, I can clearly see that 0 is less than or equal, is less than n plus 1 factorial, which is less than or equal to n factorial. And if I take the limit, n goes to infinity of 1 over n factorial, I get infinity, I get 0. So this guy obviously converges, and the 1 over n factorial gets very large very quickly in the denominator, so that's going to converge as well. So this is going to converge absolutely, and I'm not even going to have to do any more work than that. Okay, number 13. Summation n1 to infinity minus 1 to the n plus 1 n factorial over 3 to the n. Now, if this guy converges at all, it's going to be conditionally, because we know that this is going to be diverge. We know that's going to diverge. So now the issue is, does this diverge? So is 0 less than n plus 1 factorial divided by 3 to the n plus 1? Is that less than or equal to n factorial divided by 3n? So that's what the question is. I'm going to divide everything by, I'm going to divide both sides of the equation by n factorial over 3 to the n. N factorial over 3 to the n. And if I do that, I get 0 is less than n plus 1 over 3, and that's going to be less than or equal to 1. So it's n plus 1 over 3 less than or equal to 1. No. No. So this guy diverges period. There's no conditional anything. He is plain diverges. Number 8. Well, that was easy. I like that one. Number 18. Get something that gets too big too quick, and we're all done. Okay, this looks like a tricky one. Summation n equals 1 to infinity of minus 1 n plus 1 to the sine pi n over n. Okay, so we're going to have to look at this guy. When n is 1, I'm going to have minus 1 squared. The sine of pi is 0, right? And in fact, the sine is always 0. So sine pi n is always 0. If sine pi n is always 0, then this guy is just equal to 0. That looks like I'm adding up zeros. Is that what I'm doing? Really? Yeah, that's what I'm doing. So if I'm only adding up zeros, it would appear that this guy converges in a very trivial way, and he does it absolutely. That's cool. Oh, that was the last one. Okay, so now we are proceeding with 28.4, unless there's any objections. Somebody want me to work more problems or anything? I didn't think so.
Oh, you have a story for us.
I could do, I probably do, but I have to turn off the audio and the video.
Oh.
Yeah. How hosed the freshman class is. No, I'll do that. So there's my story. I'm sticking to it. So this is a power series. I can, if I have a function f of x, whatever it might be, it can be represented by a power series. N equals 0 to infinity, a n x to the n. So I could have a a0 plus a1x plus a2x squared plus blah, blah, blah. A n x to the n plus blah, blah, blah. Now, we have two types of series that we are dealing with, and let's see if we care about either of them. No, we don't care about either of them yet. Okay, now, this series is going to have some radius of convergence. So there's some x's that I could put there that this guy is going to converge, and some that the x's that he won't converge. So let's say I put in x is going to be 1/10. So I've got a0 plus a1 times 1/10 plus a2 times 100th plus a3 times 1,000th. Well, that's probably going to converge. But if I put in 10 for my x, then it's going to diverge. Okay, so we want to find the radius of convergence for that particular series. So that's what we're looking for. And it could be a plus or minus thing, so we might have to look at this could be going plus or minus on us too, so that would be the other issue. Okay, so that's what we're going to do. So I'm looking at number 1. And I got summation n equals 0 to infinity x over 2 to the n, and I want to know what are all the possible x's that this would be true for. Okay, so here's my number line up here. There's 0. So I look at this and say, well, if x is 0, well, this is true, right? So what else can be true? So that's what I'm looking for. All right, so this is summation n equals 0 to infinity x to the n over 2 to the n. And we look at limit. N goes to infinity. And this is our ratio test. So r is equal to limit. N goes to infinity. X over n plus 1 over 2 n plus 1 divided by x to the n divided by 2 to the n. Our limit n goes to infinity. I'm going to invert and multiply, and I have x over 2. Is that what I got? X over 2? Yeah, probably. So in order for this to converge, r is going to have to be, is it less than or equal to? I'm going to go back and look at my ratio test. That was last week. R has to be less than 1. That's R has to be less than 1. Okay, so x over 2 has to be less than 1 in order for this to diverge. So x could be, x has to be less than 2. X less than 2. So I'd make a number line, and I'd put a 2 right there, 2. So I know I can go between 2 and 0. Now, if this guy were, if x were a negative number, now we have to look at what happens if x is a negative number. So I've got summation n equal 0 to infinity. Is it 0 to infinity? Minus 1 to the n, x to the n over 2. Okay, so now I'm looking at a series that's doing that. Okay, so I need 0 to be less than x to the n plus 1 over 2 to the n plus 1 less than x to the n over 2 to the n. I'm going to divide both sides by x to the n over 2 to the n. So I need 0 to be less than x over 2 to be less than 1. Okay, it looks like I again, in this case, I can have x equal to 2. So x can equal 2 in this case. All right, so now I've got, on the one side, I've got all the way out, not including 2, unless I use the integral test to see if 2 is included. And on the other side, I have including 2, and then everything in between.
Is that a negative 2 or just 2?
Negative 2. So I can include, I can alternating series this guy all the way out to negative 2, but if x were a minus 3, it wouldn't work. So we're gonna come up with maple for a moment. And we're gonna look at the summation. No. Okay, we're going to look at summation. N equals, we going to 1 or are we going to, what are we going to? Thank you very much, Maple. All right, be that way. There we go, finally. All right. N equals 0, 0, and we'll go out to 10, just to go someplace. 10 of x. We're going to use minus 3. Minus 3 divided by 2 raised to the n. What happened there? What button did I push to get that?
Oh no, it's huge now.
Alright, so this is something that's getting pretty big already. So, and if we go to 100, it's, yeah, there's more on top than there is on the bottom by lots and lots. Yeah, that's better. So this thing's getting too big too quick, and it's gonna at minus 3. But if I put in a minus 2, then I get a 1 if I'm going to 100. And if I go to 1,000, I'm getting a 1. And if I go to 1,000, 100,000 and 1, I get a 0. That's not good.
How'd you get 0?
Right there, there's a 0 right there on my piece of
I
paper.
don't see it, but
So if I no, this guy at minus 2, this guy's going 0, 1, 0, 1, 0, 1, and that makes him diverge. So I can't include minus 2. Why can't I include minus 2? Well, because I hosed myself over. I forgot to take the limit as n goes to infinity of that 2 over 2 guy, which is 1, right? And I can't have a 1 there. That's got to go to 0. Yeah, the alternating series test, the guy's got to go to 0, and he's not going to 0, and he's going to 1. So that means that I can't include minus 2. There we go. So we go into my maple and do it again, and we're going to make this 1.999999999. Bummer. Brazil. That's better. That the same number?
Yeah.
That's the same number too. That's pretty much the same number too. So this is the same number we've been getting all the time, and it's added on something 10 to the minus that many zeros. So yeah, that's pretty much the same number. So 9.99, 9.999,
Changing a little bit.
9.9999. So it looks like a significant digit thing.
Yeah, it's just adding
Yeah.
0 to the significant.
Yeah. So it's a significant digit thing.
You got a 9 now.
Well, that's different.
Yeah, you're adding 6 zeros now. Well,
Yeah. So at some point, the algebra, the reason it didn't like the 0.9999999 is that it rounded it up to 2, and I can see that happening here. But in any event, we can't have a 2. So now we're back up to 1 minus 1 plus 1 again, which we wouldn't have had with 1 less 9. So we got that. This shows an imaginary number is what it's showing, as a matter of fact. And then if we throw in a 1 there. Yeah. Okay. So we're convinced that that's the case?
Yes.
That's all that matters. One person is convinced, whether or not the other 2 are irrelevant.
I'm convinced.
You're convinced too? Terrell's still out to lunch or something. Number
7.
6. 6.
Oh, yeah.
Number 6. Okay, so I got summation n equal 1 to infinity x to the n over n. Okay, so I'm going to use the ratio test again. I'm going to look at limit n goes to infinity, x to the n plus 1 over n plus 1 divided by x to the n over n. Limit n goes to infinity. I invert and multiply. So I got x n divided by n plus 1. Okay, so I'm gonna go multiply both sides by 1 over n, and I'm gonna have x. So r has to be less than 1, but r is equal to x. Therefore, x has to be less than 1. So x has to be less than 1. And now we have to look at the alternating series portion. Okay, so now we have to look at what happens in the negative direction. So I'm going to look at the a part. Is 0 has to be less than x to the n plus 1 over n plus 1, which has to be less than or equal to x to the n over n. And so I'm going to divide both sides by x to the n over n, x to the n over n. I have 0 has to be less than nx, which is less than or equal to 1. What did I do wrong? Oh, divided by n plus 1. Looks like x can be 1, but if x were anything bigger than 1, so yeah, it looks to me like x can be 1. Can be 1. But we're still going to have to look at the limit as n goes to infinity of x to the n over n. Okay, in that case, this has to be 0. And if x were 1, then that would be 0. Yeah, that would be 0. So it looks like x could be 1. Okay, so I'm gonna go with a number line. There's 0. At the top end, I have to have less than 1. So I don't include 1. At the bottom end, I can include minus 1. So it looks to me like that's probably what that is. Well, that's pretty. So back to Maple. This is number 6. So in, we're going to go from 1, and we're looking at minus 1, n. Let's see. Get rid of that. Get rid of that. Parentheses minus 1 over minus 1 raised to the n divided by n. Is that what I got? Boom. Error. Error. I'll give you an error. You liked it last time. Oh, isn't that great? Thank you very much, Maple, for your kind consideration in your description of the answer. So there's the divide line. Yeah, well, I guess that's going to be, guess we don't want it to be that big.
That's definitely one right there.
Okay, well that's small, right? That's small. And that is getting, is that smaller?
Negative. Yeah.
Yeah, it's negative, but it's getting smaller, right?
Yeah.
And we'll add another 0. And we can't tell. So we'll make it 500. And we still can't tell. Eval F. Okay, so minus 0.69. Excellent. And then we'll add 1 to it. Minus 0.69. Okay, so it looks like we're going to get there. We'll do the 1,000 guy again. Minus 0.69. All right. So it looks like we are in fact converging. Let's see. 2 more zeros. Yeah. Looking good. Okay. Minus 1. But minus 1.1. 0.01. Yes. Give me an answer, you stupid machine. Okay, so it takes a little while to do it. If I go to 100,000 of them. I don't have a control anywhere. Okay, well, we'll just go back to the next problem and wait for that to solve itself. I'm sure it will. Where are we? Number 11?
Yep.
Way to go. Yeah, that was really good. Okay, so we got summation n 0 to infinity, 2 to the n, x to the n, 3 to the n. Okay, my guess is I can go out all the way out to 2 over 3, to 3 over 2, right? Because if I go out to 3 over 2, then I'm adding a 1. So I couldn't do that. I would want to, it's going to have to be less than less than 3 over 2 is what I'm thinking about. So is Maple doing anything for me yet? No. So we can forget about Maple. So that's my guess. My guess is I can go out to 3 over 2, and I can probably include minus 3 over 2 is what I'm thinking. That's what I'm thinking. All right, so I'm going to say R is equal to limit n goes to infinity 2 to the n plus 1 x to the n plus 1 divided by 3 n plus 1 divided by 2 to the n x to the n 3 to the n limit n goes to infinity. I'm going to invert and multiply, so I'm going to get a 2n over 3, and that's got to be less than 1. So if 2 over 3 n is less than 1, n is going to have to be less than 3 over 2, which is exactly what I said it was going to be. And then we'd look at the plus and minus guy, and yeah, we're not going to bother. Come back to me, Maple.
Can you minimize Maple? Or do you have no control at all?
I have no control at all of Maple. Control, Alt, Delete. I have no Control, Alt, Delete. Oh, yeah, Control, Alt, Delete. Start Task Manager. See, Maple's running. Look at that. Pretty cool. CPU. No. Alright, so we got rid of Maple. Alright, there. Now we got rid of Maple. Now we don't have to worry about it. Okay, we'll go along with that answer for number 11, and moving on to number 23. Number 23. Summation n 1 to infinity 2x minus 5 raised to the n divided by n squared. So we're going to look at R, the limit as n goes to infinity of 2x minus 5 raised to the n plus 1 divided by n plus 1 squared divided by 2x minus 5 to the n divided by n squared. Limit n goes to infinity. I'm going to invert and multiply. Okay, so I've got n 2x minus 5 divided by n plus 1 squared, and that all is supposed to be less than 1 is what I'm looking for, that condition. Alright, so I've got limit n goes to infinity and 2x minus 5 divided by n squared plus 2n plus 1. I'm going to multiply top and bottom by n squared, top and bottom by 1 over n squared. Limit n goes to 0, infinity, of 2x minus 5 over n divided by 1 plus 2 over n plus 1 over n squared. That guy goes to 0, this guy goes to 0, that guy goes to 0. It looks like I've got R is 0. In which case it wouldn't matter what x is? That's hard to believe.
X is infinity?
Yeah, that's hard to believe. All right, go back into Maple. We won't ask Maple to do the impossible this time. Maybe. Okay, so we're going to go n is going to go 1 and 1 to we'll just go to 10. 10. And we're going to go 2 times x minus 5 raised to the n. Really? Yeah. Divided by n squared. Okay, we're going to start with x being 10. X being 100. So obviously there's some limit on what can be there. X be 5. No.
5, 3.
X be 3. Maybe. Can't tell. Thank you. Oh, the colon suppresses the answer. Looks to me like maybe what's 5 over 2? 3 is bigger than 5 over 2, right?
Yeah.
6. I'm going to try a 4. No?
Or the book, that is.
Yeah, 4 doesn't work.
It says it has to be, x has to be less than or equal to 3, but greater than or equal to 2.
Let's try 2.5.
2.5. Yeah. So how come we don't get a 3? That's the issue. Okay, what did I do wrong? Okay, so I got that guy right. X to the n squared, n plus 1, n plus 1. N there. That guy's there. This guy's here. And n squared to n. Okay, so there's something I'm doing wrong. Is this the last problem I have to work?
Yes.
Oh. So I don't technically have to get it right. N goes to infinity. So we want this to be this isn't n. This is n squared. That's the problem. That's n squared. And because that's n squared, then this becomes 2x minus 5 over 1 plus 2 over n plus 1 over n squared, limit, n goes to infinity. This becomes 0, that becomes 0, this has to be less than 1. So 2x minus 5 has to be less than 1, implying that x has to be less than 3. But it says it can be equal to 3?
It says it can be equal to 3 also.
So I don't see how they get equal, unless this is less than or equal to here, and I'm just goofing off and
If
putting
it's
all
equal
of
to
it
3,
down.
2 times 5 is 2 times 3 is 6, minus 5 is 1.
Well, it says if I'm equal to 1, I have to use some other test to see whether or not it converges. All right. So how do I get the other side? Oh, yeah. So basically 2x minus 5, that absolute value has to be less than 1. In case 1, that would be less than 3. But if 2x minus 5 is less than 0, then minus 2x minus 5 has to be less than 1. So that'd be minus 2x plus 5 less than 1. And then minus 2x less than minus 5, x has to be greater than 2.5. So now my answer is going to be between 2.5 and 3. And we include both of them or disclude both of them?
You would include them.
So we're going to include both of them. My backup book. Okay, all done with that. What's coming next? Oh, cool things are coming next. Excellent. Now what do I want to do? Control Alt